Welcome back. In this video we're going to explore the concept of the chain rule, and what the chain rule will do is find the derivative of the composition of two or more functions. That should be the. And so what we have is we kind of pull these apart. So if y equals f of g of x, you can find the derivative. I like this format of the derivative. It's the derivative of the outer function at the inner function times the derivative of the inner function. You'll see me break it down the first few times into these u's and rewrite y and all that stuff. As we go deeper into the class, I won't do that, and I expect that at the beginning you'll have to identify what u is and write it out, but as we get deeper into this assignment, you won't have to do that either. This will seem confusing at first, but the nice thing is that you will master it very quickly because you have to, because it's built into almost every derivative we do for the rest of the semester. My first example, y equals the square root of 2x minus 3. The inside function here would be the 2x minus 3, so u would equal 2x minus 3. And then du over dx would be 2. If you rewrite y in terms of u, it would be the square root of u, or u to the 1/2. That's the format you need to take the derivative. When I find the derivative dy dx, it's going to be 1/2 of u to the negative 1/2 times du dx. You're going to plug everything back in, so I'm going to put in 2x minus 3 right there, and I'm going to put in 2 right there, so it's going to be 1/2 times 2x minus 3 to the negative 1/2 times 2. These will cancel, and I am left with 1 over the square root of 2x minus 3, and that is my derivative. In my next example, I have something raised to a very large power. I wouldn't ask you to raise a trinomial to the 50th power. In this case, u would be x squared minus 2x plus 1. Du over dx would be 2x minus 2. Y would be u to the 50th. And dy over dx would be 50 u to the 49th times du over dx. So in my particular example, plug everything back in, dy over dx would be 50 times x squared minus 2x plus 1 to the 49th, and then times 2x minus 2. Another way of thinking about it, and this is the way a lot of people teach it, and sometimes I look at it this way, is take the derivative of the outer function. Outer function is raised to the 50th power, so take the derivative of that, bring the 50 down, reduce it to 1, reduce it by 1 to 49, and then multiply by the derivative of the inner function. So another way of looking at it would be dy dx. If I bring the 50 down, it would be 50 times x squared minus 2x plus 1 to the 49th, and then times 2x minus 2. Which is the derivative of the inner function. Either way is fine. I'll give you the same answer. What I expect is that for this first part, you'll probably do this, and then as you get better at it, you'll get to this. We can do it with negative exponents. We can do all kinds of different things. So in this particular case, the 3 minus x would be u. So du over dx would be negative 1. Rewrite it as y equals u to the negative 5th power. So dy dx would be negative 5 u to the negative 6 times du dx. And then plug everything back in. So dy dx would be negative 5 times 3 minus x to the negative 6 times negative 1. Those negatives will drop out, and I'm left with 5 over 3 minus x to the 6th. Throw in some trig. Cosine of 2x, because that 2 on the angle, that's got to be u. So u is 2x, du is 2 dx. So when I go to rewrite or go to find this derivative, y would be the cosine of u. Dy over dx would be negative sine of u times du over dx. In this particular case, it would be negative 2 sine of 2x. Sometimes you can combine like things like product rule with our chain rule. So to do something like 2x minus 5 cubed times 4 minus x squared, and I want to find the derivative of that, it's going to be dy dx is going to be 3 times 2x minus 5 squared times 2 times 4 minus x squared. That's the first part of product rule. And the second part of product rule would be plus 2 times 4 minus x times negative 1 times 2x minus 5 cubed. This 2 comes from our chain rule, derivative of 2x minus 5. This negative 1 comes from chain rule because of 4 minus x. I then need to simplify it. I'm going to factor out what they have in common. In each case, they have a 2 in common, so I'll pull that out front. They have a 2x minus 5 squared in common, and they have a 4 minus x in common. And then what's left over on this first one, I have a 3 times 4 minus x. On the second one, I have a negative 1 times 2x minus 5. And then finally, to get your answer, that would be what? 12 plus 5 is 17. And then negative 3x minus 2x is minus 5x. And we do have to simplify it that far. Yeah, I do expect you to be able to do that. And then every once in a while you run into a problem like this where I have the tangent cubed of 4x, which is chain rule within chain rule. Really what this means is something like this. It's tangent of 4x cubed. And then you got to take the derivative of each piece. So you have a derivative within a derivative or a chain rule within a chain rule. So dy dx would be 3 times tangent of 4x squared times the derivative of tangent of 4x, which is secant squared of 4x times 4 because of the 4x. And then the only thing you can really do to simplify it is just multiply the 3 and the 4. So it'd be like 12 tangent squared of 4x times the secant squared of 4x. All right, so like I said, chain rule is something you have to become good at, so you will. I'll clarify some more, do some more examples in class for you, hopefully get you headed in the right direction.